Picture this, a colossal rock, hurtling through the vast emptiness of space on a collision course with our planet. It's a scenario straight out of a science fiction film, but the threat of an asteroid impact is a danger that has haunted humanity for centuries, and it's a threat that we can no longer afford to ignore. Our history is filled with reminders that we are not alone in the cosmos. 66 million years ago, an asteroid estimated to be about 6 miles wide slammed into Earth near the Yucatan Peninsula in Mexico. This catastrophic event, known as the Chicxulub impact, triggered widespread wildfires, tsunamis, and a global dust cloud that plunged the planet into darkness. It wiped out the dinosaurs along with countless other species, forever altering the course of life on Earth. But the Chicxulub impact is just one example of the many times asteroids have left their mark on our planet. From the Barringer crater in Arizona, a mile-wide scar carved out by an impact 50,000 years ago, to the Tunguska event in Siberia in 1908, where an asteroid exploded in the atmosphere with the force of 1,000 Hiroshima bombs, the evidence is all around us. These cosmic collisions, though rare, are a stark reminder of our planet's vulnerability in the vast expanse of space. The universe is a shooting gallery, and Earth is a moving target. While the dinosaurs met their fate due to an unfortunate cosmic coincidence, we, their intelligent descendants, are not content to simply wait for the next big one. We are actively scanning the skies, developing innovative technologies, and preparing to defend our planet from whatever the cosmos throws our way. The Earth is constantly bombarded by small objects from space, most of which burn up harmlessly in the atmosphere. But larger asteroids, those exceeding a certain size, pose a significant threat to life as we know it. Scientists estimate that there are millions of asteroids in our solar system, ranging in size from pebbles to dwarf planets. Most of these asteroids reside in the asteroid belt, a region between Mars and Jupiter, but some have orbits that cross Earth's path, making them potentially hazardous. These near-Earth objects, or NEOs, are our primary concern when it comes to planetary defense. While the odds of a large asteroid impact in our lifetime are slim, the consequences would be devastating. A direct hit from a large asteroid could cause widespread destruction, triggering earthquakes, tsunamis, and global climate change. Even a smaller asteroid, if it were to strike a populated area, could cause significant damage and loss of life. The good news is that we are not sitting ducks. Scientists and engineers around the world are working tirelessly to detect, track, and characterize these celestial threats. We are developing advanced telescopes and early warning systems to give us as much lead time as possible in the event of a potential impact. To understand how we can protect our planet from asteroid impacts, we need to delve into the fundamental forces that govern the universe. One of the most powerful is gravity. Gravity keeps our feet on the ground and prevents us from floating off into space. It's the invisible glue that holds the universe together. Gravity is the force of attraction between any two objects with mass. The more massive an object, the stronger its gravitational pull. The closer two objects are, the stronger the gravitational force between them. This force causes planets to orbit stars and moons to orbit planets. Even galaxies cluster together due to gravity. Sir Isaac Newton first described the law of universal gravitation. He showed that every object attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. Even objects separated by vast distances like the Earth and the Sun exert a gravitational pull on each other. The Sun's enormous mass keeps Earth in its orbit, while Earth's gravity keeps us and everything else on its surface from drifting off into space. Gravity may seem like an unstoppable force, but what if we could harness its power, turning it from a potential threat into our very own planetary shield? Believe it or not, scientists and engineers are exploring ways to do just that. Remember those near-Earth objects, the asteroids that pose a potential threat to our planet? Well, instead of trying to blow them up like in the movies, which could create a potentially even more dangerous swarm of debris, we could use gravity to gently nudge them off course. This is where the ingenious concept of a gravity tractor comes in. Imagine a spacecraft, not too dissimilar from the ones we use to explore other planets, but with a very special purpose: to act as a gravitational tugboat for asteroids. The idea is deceptively simple. Position a spacecraft close to a potentially hazardous asteroid and let the spacecraft's own gravity, albeit weak, exert a gentle but constant pull on the asteroid over an extended period. Section 5. The gravity tractor. A gentle nudge. The gravity tractor wouldn't be a brute force solution, shoving the asteroid out of the way like a cosmic linebacker. Instead, it would be more like a delicate dance, a subtle gravitational ballet. The gravity tractor spacecraft positioned near the asteroid wouldn't even need to touch it. The spacecraft's own mass, while minuscule compared to the asteroid, would create a gravitational pull. This pull, though weak, would be constant. Over time, like a persistent ant moving a crumb, this constant tug would subtly alter the asteroid's trajectory. The key to the gravity tractor's success lies in time. The earlier we detect a potentially hazardous asteroid, the more time we have to alter its course. Even a tiny deflection applied steadily over months or years could be enough to nudge the asteroid away from Earth's orbital path, averting a potential disaster. The gravity tractor concept has several advantages over other proposed asteroid deflection methods. It doesn't require us to land on the asteroid, which could be difficult and risky, especially if we're dealing with a rapidly rotating or porous object. It also doesn't involve the use of explosives, which could fragment the asteroid and potentially make the problem worse. Section 6. A delicate dance. Timing and precision in space. The grace of the gravity tractor method lies in its subtlety, but this subtlety comes at a price tag. The earlier we detect a potential threat, the better. Early detection provides us with the luxury of time, allowing us to deploy a gravity tractor and make the necessary trajectory adjustments. Imagine a game of cosmic billiards, where the Earth is the 8-ball and a rogue asteroid is the cue ball hurtling towards it. If we only spot the cue ball at the last second, our options are limited. We might try to hit it hard with a powerful deflection method, but the risk of a miss or a miscue is high. But if we spot the cue ball early on, while it's still far from the 8-ball, we have time on our side. We can take a more calculated approach, using the gravity tractor to gently nudge the cue ball ever so slightly, changing its course and ensuring the 8-ball remains untouched. This early detection and response time is crucial for the gravity tractor concept to be effective. The further away the asteroid is, the smaller the deflection needed to alter its course. A small nudge applied years in advance can achieve the same result as a much larger nudge applied closer to Earth. Section 7. Challenges and solutions. Fueling our defense. The gravity tractor concept, while elegant in its simplicity, is not without its challenges. Building and launching any spacecraft is a complex and costly endeavor, and the gravity tractor is no exception. One of the main challenges is fuel. To maintain its position near the asteroid and exert a constant gravitational pull, the gravity tractor spacecraft would need a reliable source of propulsion. Solar electric propulsion, which uses sunlight to generate thrust, could be a viable option for long-duration missions. Another challenge is the precise navigation and control required to keep the gravity tractor in the optimal position relative to the asteroid. This would require advanced sensors, autonomous navigation systems, and robust communication with Earth-based controllers. The mass of the spacecraft is also a factor. A more massive spacecraft would exert a stronger gravitational pull, but it would also require more fuel to launch and maneuver. Scientists are exploring ways to enhance the spacecraft's gravitational influence, perhaps by using a tethered counterweight, or even capturing and redirecting a smaller asteroid to use as a natural gravity tractor. Despite these challenges, the gravity tractor concept remains a promising avenue for asteroid defense. Technological advancements in propulsion systems, autonomous navigation, and spacecraft design are bringing this concept closer to reality. Section 8. Planetary protectors, current efforts, and future visions. We are not alone in our efforts to protect our planet from cosmic threats. Around the world, space agencies and research institutions are actively engaged in planetary defense initiatives. NASA, the European Space Agency, and other organizations are constantly monitoring the skies, tracking known near-Earth objects and searching for new ones. They use ground-based telescopes, space-based observatories, and sophisticated data analysis techniques to identify potential threats. One notable effort is NASA's Double Asteroid Redirection Test, which successfully slammed a spacecraft into a small asteroid in 2022. This mission was designed to test the kinetic impactor technique, where a high-speed spacecraft is used to slightly alter an asteroid's trajectory. Looking to the future, scientists and engineers are exploring a wide range of innovative asteroid defense strategies. These include laser ablation, where lasers are used to vaporize asteroid material and create a jet plume that acts as a natural thruster, and mass drivers, which use electromagnetic fields to hurl material off the asteroid's surface, creating thrust. International cooperation will be essential for any successful planetary defense effort. Sharing information, resources, and expertise will be crucial for developing effective strategies to mitigate the threat of asteroid impacts. Section 9. Our Cosmic Destiny, Innovation in the Face of Uncertainty. The cosmos is a vast and awe-inspiring place full of wonder and beauty, but it also presents us with challenges. The threat of asteroid impacts is a stark reminder of our planet's vulnerability in the grand scheme of things. But we are not a species that cowers in fear. We are explorers, innovators, and problem solvers. We have faced challenges throughout our history, and we have always found ways to overcome them. The quest to protect our planet from asteroid impacts is not just about survival. It's about pushing the boundaries of human ingenuity. It's about daring to dream of a future where we have the knowledge and the tools to safeguard our world from cosmic threats. By harnessing the very laws of physics that govern the universe, by embracing innovation and collaboration, we can become the guardians of our own destiny, ensuring that humanity's journey on Earth continues for generations to come. The cosmos may have thrown us a curveball, but we are ready to step up to the plate, bat in hand, and show the universe what we are made of.